In this episode, we're going to take a problem that shows up the moment teams start automating anything at scale, and we're going to make it feel manageable instead of messy. Environment provisioning sounds simple at first because it is just getting a place ready to run software. But it quickly becomes complicated when you need the same steps repeated across laptops, test environments, and production-like systems. The temptation is to keep stuffing more and more setup logic into the pipeline until the pipeline becomes the only place the environment can be built, understood, or repaired. That is what pipeline sprawl looks like, and it creates fragility because every small change becomes a risky edit to a long chain of steps. Task runners give you a cleaner approach by letting you define repeatable operational tasks in a consistent way, so the pipeline can call those tasks instead of becoming a giant script graveyard. The goal is not to worship a tool, but to build a mental model for how to keep provisioning logic reusable, testable, and readable. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. The most helpful way to understand a task runner is to think of it as a tiny conductor that knows how to run named tasks in a predictable sequence, with clear boundaries between tasks and consistent inputs and outputs. Instead of treating provisioning as one huge blob of steps, you treat it as a set of deliberate actions like prepare prerequisites, validate configuration, create resources, and confirm readiness. A task runner can live close to the code and configuration that it supports, which keeps operational knowledge from drifting into random wiki pages or hidden pipeline scripts. This matters because provisioning is rarely a one-time event. It is something you redo when you build a new environment, recover from failure, or change a baseline. When that logic is embedded directly inside a pipeline, the pipeline becomes the only source of truth, which is awkward because pipelines are optimized for running jobs, not for expressing and maintaining operational intent. By putting the intent into tasks, you make it easier for both humans and automation to call the same actions consistently. Pipeline sprawl happens when the pipeline stops being a coordinator and becomes the place where every detail of environment setup is hard-coded. At first, this feels efficient because you see everything in one place, and the pipeline is already running, so adding more steps seems harmless. Over time, though, the pipeline becomes harder to reason about because it contains conditionals for different environments, repeated snippets for slightly different contexts, and one-off fixes that were added during stressful incidents. The result is a pipeline that is long, fragile, and expensive to change, even for small improvements. Another cost is that local validation becomes difficult because a developer or operator cannot easily run a subset of provisioning tasks without simulating the full pipeline environment. That encourages a slow loop where people push changes just to see if provisioning works, which wastes time and increases risk. A task runner helps you avoid that trap by moving the provisioning logic into a shared, runnable set of tasks that can be executed consistently in multiple contexts. Provisioning itself has a predictable set of concerns that task runners handle well because they force you to name and structure those concerns. Every environment needs some mix of configuration, dependencies, connectivity, identity, and readiness checks, even if the details differ across systems. Beginners sometimes think provisioning is only about creating resources, but operationally it is also about verifying that prerequisites exist, that permissions are correct, and that the environment is in a safe state before work begins. If you skip those checks, automation becomes brittle because it assumes the world is always clean and aligned, which is rarely true. A task runner makes it easier to encode those checks as first-class tasks rather than as scattered lines buried inside a long pipeline job. When checks are tasks, they can be called before and after changes, which gives you a safer rhythm of validate, act, then verify. That rhythm matters because it turns provisioning from a risky leap into a controlled sequence. A big benefit of task runners is that they encourage idempotent behavior, meaning running the same task multiple times leads to the same end state rather than creating duplicates or breaking the environment. Idempotency matters in provisioning because retries are normal, whether due to transient network failures, rate limits, or partial system outages. If your provisioning logic cannot be safely rerun, every failure becomes a manual cleanup exercise, and manual cleanup is where mistakes multiply. When tasks are explicitly defined, you can design them to check current state, apply changes only when needed, and confirm the result, which supports safe reruns. This also makes troubleshooting easier because you can rerun just the failing task rather than rerunning an entire pipeline and hoping the failure repeats in the same way. Beginners often assume that automation is either successful or broken, but in reality, many failures are partial, and partial failures are exactly where idempotent tasks shine. A task runner helps you build that safety into your habits by making reruns a normal part of the workflow instead of an emergency move. Another way task runners reduce sprawl is by making dependencies between tasks explicit instead of implicit. In messy pipelines, a step depends on a previous step because it happens to appear earlier in the script, and that kind of ordering becomes fragile when someone rearranges steps or inserts a new one. With tasks, you can express that one task requires another task to have completed, and you can separate setup steps from execution steps so the environment is built in a controlled way. This is especially important in provisioning because some actions must happen in a specific order, such as creating an identity before granting permissions or establishing a network boundary before deploying services. When those dependencies are unclear, failures become confusing, and people fix them by adding more conditionals and sleeps, which makes sprawl worse. Task runners push you toward a clearer structure where tasks are small, named, and ordered for a reason. That clarity is not just aesthetics. It is how you prevent repeated breakage when environments evolve. It also helps to recognize that provisioning is not only about creating things, but about standardizing the environment's baseline so the same software behaves the same way in each place it runs. Baseline thinking includes operating system settings, runtime versions, configuration files, and external dependencies that the application relies on. If your baseline is inconsistent, the application might work in one environment and fail in another, and troubleshooting becomes guesswork because the environments are not comparable. Task runners support baseline consistency by defining a repeatable set of tasks that establish and validate the baseline before anything else happens. This is where beginners often misunderstand the purpose of automation because they focus on speed rather than consistency. Speed is useful, but consistency is what makes speed safe because it reduces surprise. When the baseline is created through tasks rather than buried pipeline steps, it becomes easier to review, test, and adjust intentionally as requirements change. Task runners also help you keep a clean boundary between orchestration and implementation, which is an operational design pattern that reduces long-term maintenance cost. Orchestration is deciding what should run and when, while implementation is the details of how a particular action is performed. Pipelines are naturally good at orchestration because they can trigger jobs, coordinate stages, and react to outcomes. They are less good at being the permanent home of implementation detail because pipeline syntax tends to be noisy and environment-specific. By putting provisioning details into tasks, you allow the pipeline to remain a coordinator that calls tasks like provision, validate, or tear down, without knowing every internal step. This separation makes changes safer because you can adjust the task implementation while keeping the pipeline stable, and you can reuse the same tasks across multiple pipelines or environments. Beginners sometimes expect the pipeline file to explain everything, but operationally it is better when the pipeline reads like a high-level story and the task runner holds the detailed logic. Another important angle is reproducibility, which means you can create the same environment again later and get the same results. Reproducibility matters for debugging, because when an issue happens in a test environment, you want to recreate the environment to confirm the fix. It also matters for audits and incident reviews, because you need to explain what configuration existed at the time of an event. When provisioning logic lives only in a pipeline, reproducibility can become fragile because the pipeline may change over time, and older behavior may not be easy to recover. With task runners, you can treat the tasks as versioned assets alongside the code, which helps tie a given build or release to the provisioning logic that supported it. That does not mean environments are frozen forever, but it does mean changes are intentional and traceable. For beginners, reproducibility is a practical way to reduce stress because it turns one-off mysteries into repeatable experiments you can reason about. Security is also tighter when task runners are used thoughtfully, because they reduce the temptation to embed sensitive operational details inside pipeline scripts and logs. Provisioning often touches credentials, permissions, and service identities, and those interactions need to be controlled and auditable. When pipelines grow sprawling, they often accumulate ad hoc secret handling, which increases the chance of secrets leaking into logs or being copied into inappropriate places. A task runner encourages a cleaner interface where the pipeline provides only what is necessary, and the task execution environment handles sensitive operations in a controlled way. This pairs well with principles like least privilege and short-lived access because tasks can be designed to request only the permissions they need for the specific operation. It also makes it easier to enforce consistent checks, such as verifying that a deployment identity is correct before applying changes. Even as a beginner, you can appreciate that secure provisioning is not about hiding everything, but about keeping sensitive actions predictable, scoped, and observable. Observability is another place where task runners quietly improve operations, because they create natural checkpoints and meaningful task boundaries that can be logged and measured. When a pipeline is one long script, logs tend to be a flood of lines that are hard to group into meaningful phases. With tasks, you can see which task started, which task finished, and where failure occurred, which makes it easier to diagnose issues without scanning thousands of lines. This is especially valuable in provisioning because failures can happen at many layers, such as network reachability, identity permissions, configuration parsing, or dependency availability. If tasks are well designed, they can surface errors at the right level of abstraction, meaning the error message is connected to a specific task, like validate configuration rather than buried deep in unrelated output. That makes communication clearer during incidents, because you can say the environment failed during validation rather than saying the pipeline failed somewhere. Clear boundaries also support metrics, because you can track how long certain tasks take and detect drift when a task starts taking much longer than usual. That drift can be an early warning of underlying problems. Failure handling becomes more mature with task runners because they encourage you to think about recovery paths as part of the design rather than as an afterthought. Provisioning sometimes fails halfway through, leaving an environment in a partially changed state, which is a dangerous place because it is neither the old state nor the intended new one. If the only way to recover is to rerun a huge pipeline, teams hesitate, or they start making manual edits, which often makes the environment more inconsistent. A task runner gives you a more controlled approach because you can rerun a specific task, run a cleanup task, or run a verification task to assess the environment's current state. This supports safer remediation because you can take smaller steps and confirm outcomes after each one. Beginners often imagine troubleshooting as finding the one magic fix, but operators think in controlled moves that reduce uncertainty. Task runners make those controlled moves easier because tasks are already packaged as discrete actions. Another practical benefit is that task runners support consistency across local development, shared testing environments, and automated pipelines, which reduces the common problem where something works locally but fails in the pipeline. When tasks are runnable in multiple contexts, the same provisioning actions can be used to prepare a local environment, validate a test environment, or set up prerequisites for a deployment. That consistency reduces surprises, because the pipeline is not doing a secret set of steps that nobody can reproduce outside the pipeline environment. It also supports learning, because beginners can understand provisioning as a set of named actions rather than as an opaque script that only runs in a remote system. This does not mean every developer needs to run provisioning tasks constantly, but it does mean the operational story is accessible and testable. When the story is accessible, mistakes are caught earlier and corrected with less drama. That is how you prevent sprawl. You make the right behavior easy to repeat and easy to understand. Governance and change control also become more practical when provisioning logic is organized through tasks, because review can focus on meaningful units rather than on huge pipeline diffs. When a provisioning change is introduced, reviewers can see which task changed and why, and they can reason about impact more clearly. This matters because provisioning changes can have broad effects, and broad effects deserve careful scrutiny even when the team moves fast. Task boundaries also help with documentation in a natural way because the task name and description become a form of documentation that stays close to the code. When documentation is separate from the implementation, it drifts and becomes unreliable. When documentation is embedded in the structure of tasks and their intent, it stays more aligned because changes to tasks are visible in the same place. For beginners, this is an important lesson. Clarity is a security control and a reliability control because unclear systems are easier to misuse and harder to fix. Task runners are a practical way to build clarity into provisioning workflows. As you bring these ideas together, the main outcome is that task runners help you keep pipelines small, readable, and resilient by moving environment provisioning logic into reusable, named tasks that can be executed consistently. The pipeline remains the conductor that triggers work and coordinates stages, while the task runner owns the operational actions and their dependencies, validation, and recovery options. This reduces pipeline sprawl because you stop adding one-off steps directly to the pipeline and instead improve the shared task set that every context can use. It also improves safety because idempotent tasks support retries, explicit dependencies prevent ordering mistakes, and clear task boundaries improve troubleshooting and observability. Security improves because secret handling and permission use can be scoped and standardized rather than scattered across pipeline scripts. For a beginner, the key mental model is simple and durable. Build environments through reusable tasks with clear intent, and keep the pipeline focused on orchestration rather than details. When you can explain that model and recognize sprawl as a sign that the boundary has been violated, you are thinking like an operator who can scale automation without losing control.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.